I want to go over homework problem number 2 from section 3.6. We want to find the steady periodic solution and the actual solution of the given differential equation, and then write the solutions in this form. We are given the following differential equation and the initial conditions. And then we want to graph them. Once I have the solution, or once you have the solutions, you really need a graphing tool to graph the functions. So to find the solution for this one, to find the steady periodic solution or the particular solution, we are going to look at, oops, this is not a 0, sorry, that should be 5 cosine of 4t. When you want to find a particular solution, you're going to say that because of this cosine of 4t, you're going to say the particular solution is going to be some coefficient of cosine of 4t plus b sine of 4t. That's how you start finding the particular solution. And then you are going to find the derivative and the second derivative, and then substitute the second, the first derivative, and the equation here, set it equal to 5 cosine of 4t, and then solve for a and b. That's what we want to do. So to do that, we are going to find the second derivative, first derivative. Derivative of cosine of 4t is negative sine of 4t times derivative of this angle. Derivative of sine is cosine of 4t times derivative of this angle. Then we find the second derivative. Derivative of sine is cosine of 4t times 4, but then 4 times negative 4 gives us negative 16. Derivative of cosine is negative sine 4t times 4b. So then I'm going to substitute, and I'm going to substitute it this way. I need 2 times x, so I need to multiply this by 2. I need 2x prime, so I need to multiply that by 2. Then I have x double prime. I leave that as is. And then I know that if I add all these, I'm just going to get 5 cosine of 4t. And then when we're solving these, we want to add our cosines together. And then set it equal to that, and then we want to add the sines together and set it equal to 0. And the reason we set it equal to 0 because we don't have a sine on this side. So I get 2a cosine 4t, but I'm not going to write the cosines because they cancel each other. When I set it equal to 5 cosine of 4t, cosines cancel each other. So I just get the coefficient. I have a 2a here. I have a minus 16a. And then I have 2 times 4 is 8b equals to 5 cosine of 4t. Again, cosines are gone. Then I have b, 2 times b from this equation. I'm just going to write 2b here. And then I have minus 16b here. And then I have 2 times negative 4 is negative 8a plus 2b minus 16b is equal to 0. because you can look at it as a plus 0 sine of 40. So there's a 0 here, so you set the sines equal to 0, you set the cosines equal to 5 cosine of 40. Sines and cosines on both sides cancel each other. This is what we get. 2 and minus 16 gives us negative 14. Negative 8a. 2 and negative 16 gives us negative 14b. I'm going to, you can use elimination method or Gauss elimination method. I'm going to use substitution method. I'm going to solve for a from the second equation. So I'm going to isolate a, move negative 14 to the other side, then divide by negative 8. So I get a is equal to negative 14 over negative 8, b, which a is going to get reduced to negative and negative is positive. So, and 14 and 8 are both divisible by 2. That's what I get. And then I'm going to substitute 7/2b here. Add it to a b, set it equal to 5. So let's reduce, I'm sorry, this is not a 2, that's a 4. They're both divisible by 2, I get 7 and 4. So 4 and 14 are reduced, I get 7. And again, when I move this 14, this becomes positive. So many mistakes I made, sorry about that. That's a positive because I add a 14b to both sides. So this is positive divided by negative. This is negative, really. So this is negative here. So I have a negative. So negative times negative is going to be positive 49 over 2b plus 8b. I'm going to multiply this 8 by 2 over 2, so they have the same denominators. 14 and 16 and 49 is 65b. I'm going to multiply both sides by 2 over 65 to get b isolated. Um, 65 divided by 5, 13. So we get b is equal to 2 over 13. And we know that a is equal to negative 7 over 4 times b. So we get negative 7 over 26. So now we have a and b. So then our particular solution is going to be negative 7 over 26 cosine 4t plus b, which is 2 over 13 sine of 4t, because this is what we had at the very beginning here. So we found a, we found b, that is what x is going to look like. Let me highlight it. Later, we are going to put it in the cosine form, like c cosine of omega t minus alpha. But let's find the complementary solution. So we say x of, to find a complementary solution, x of c, we need to solve the characteristic equation. So we have x double prime plus 2x prime plus 2x is equal to 0. And we are going to let x equal to e to the power rt. We substitute x prime, which is going to be r e rt, and x double prime is going to be r squared e rt. So we're going to substitute these into this equation. Since every term has an ert and 0 on the other side, ert's go away. So we just get x double prime r2 plus 2r plus 2 is equal to 0. To solve this, we are going to use quadratic equation. A is 1, this is B, and this is C. So we get minus B plus minus B to the power 2 minus 4 times A times C divided by 2 times A. So 4 times 2 is 8, 2 times 2 is 4. 4 minus 8 is negative 4, so we get a square root of, here we get a square root of minus 4, which we can write as 4 square root of minus 1, which is 4i. So we get r is equal to negative 2 plus minus 2i divided by 2. This 2 gets reduced by both of them, so r is negative 1 plus minus I. So since that is what we have for r, we know that xc, or complementary solution, is going to be e minus t, some coefficient of cosine of 1t plus c2 sine of 1t. But I want to find c1 and c2. To find c1 and c2, we know that x of t is x of complementary plus x of particular. Using the initial conditions I have, I can find c1 and c2. So x of t is equal to e minus t c1 cosine of t c2 sine of t plus x of or the particular solution was negative 7 over 26 cosine 4t plus 2 over 13 sine 4t. We are going to find x at 0, which is 0. X at 0 is 0. That's one of our initial conditions that was given to us. So we are going to substitute 0. 0 here, 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 and here. So remember, cosine of 0 is 1, and sine of 0 is 0, and e to the power negative 0 is also 1. Okay? So this gives us 1. C1, cosine of t is going to be 1. Sine of t is 0. So that's going to be 0. 0 times c2 is 0. Minus cosine of 4 times 0 is cosine of 0. Cosine of 0 is 1. So we get minus 7 over 26 plus sine of 4 times 0 is 0. Sine of 0 is 0 times 2 over 13 is 0. So that gives us 0 equals to c1 minus 7 over 26, or c1 is 7 over 26. Again, I'm going to use the second condition, x prime of 0 is 0. So for that reason, I need to find x prime of t. For this part, I'm going to use the product rule for the first term. I'm going to use product rule here. So derivative of e to the power negative t is going to be negative e to the power negative t times the second factor. I have to find derivative of the second factor. Derivative of c1 cosine is negative c1 sine of t plus derivative of sine is cosine, c2 cosine of t. And then I have to find derivative of that piece, which is minus, derivative of cosine is gonna be negative sine, negative and negative makes that positive 7/26 times derivative of the angle, which is 4. Derivative of cosine is sine of 4t. Derivative of sine is cosine of 4t times 4 times that coefficient. So I get 2/13 times 4. That 4 is the derivative of the angle. So let's again substitute 0 here and see what we get. So this is going to be 0. X prime of t is 0 when t is 0. So I put 0 here. I get e to the power 0 is 1. I get negative 1. This is going to be 1. This is going to be 0. So I just get c1. But c1 is 7/26 times 1 plus c2 times 0 is 0. E to the power negative 0 is 1. Sine of 0 is 0, cosine of 0 is c2, so I get c2. And when I put 0 here, sine of 0 is 0, times that is 0. If I put 0 here, cosine of 0 is 0, I get 8/13. So what I have here is negative 7/26 plus c2 plus 8/13. So we want to solve for c2. How about if I multiply that by 2/2 so they have the same common denominator. 16 take away 7 is 5/26. Right? 16 minus 6, 16 minus 7 is 5. No, sorry, it is 9, not 5, 9. 9/26, right? 9 and 7 is 16. So I get 9/26 and I add these two. So I have 0 is equal to C2 plus 9/26. And therefore C2 is equal to negative 9/26. So I have C1 and I have C2. Let's write our equation. Solution xt is equal to 7/26 okay. E to the power negative t, 7/26 cosine t, negative 9/26 sine t, plus, or minus, rather, this equation, 7/26 where's my equation? Cosine of 40 and 2/13 sine of 40. So we are done. You have your equation, but the only thing is they don't want you to use your answer like that. They want you to change your answer, and they want you to put your answer in this form. For both of them. And there is a formula that says, if I want to find that capital C, I have this formula that says this is equal to a squared plus b squared. So I need to find this is squared and that is squared. So C is equal to 7/26 to the power 2, negative 9/26 to the power 2. So let me use my calculator. 7 I get 0.4385. We have to round this to 3 decimal points. So you say C is 0.439. Okay, that's the C for this one. Let's find C for the other one as well while I'm at it here. C for these two together. So again, I use the same formula. I'm going to write C is equal to -7/26 squared on 2/13 squared. And for this one, I get C is 0.3100. C is equal to 0.310. Okay, so that is the C we picked for the other one. Now that I have found your C, you have to find the angle, right? Because the formula that I wrote earlier here, so you found C, we have omega is already given to us. We need to find that angle alpha, that shift. So how do I find that angle alpha? What you have here is 7/26 cosine t minus 9/29 sine t. If you think of this as, one way to think of it is cosine alpha cosine beta plus sine alpha sine beta. This is equal to cosine of alpha minus beta. That is the formula. So do you see you have your cosines, you line them up, you have your sines, you line them up, and then these are your cosine and sine, okay? That's how I do it, but the better way of doing it, they put this capital C here, and they say this is cosine of alpha minus beta, and then they distribute the C as well, so that C becomes the denominator for this C, but this is enough if you think of it like that. And in reality, this is a negative. So in reality, we can just get rid of that, put a plus, and this is a negative, okay? So you're saying that cosine of alpha is 7/26. So this is not correct. I have to have that C, but if I don't have that C right now embedded in there, I still could use this analogy. So I have sine of alpha is negative and cosine of alpha is positive. So when does this happen? This happens in this quadrant. In this fourth quadrant, I have cosine is positive because x-axis is positive and sine is negative. Cosine is positive, sine is negative. So, and then you also know that if you're looking for, if this is your sine of alpha, this is your cosine of alpha, and you want to find this angle here, you can say tangent of alpha is equal to sine of alpha over cosine of alpha. Even if you have that C, they would cancel. So then you just say -9/26, 7/26. So you say alpha is equal to inverse tangent, -9/7. There is a problem. When you put this in your calculator, since tangent is negative here, it's going to give you the angle for this one. Or you may get, I'm so sorry, you don't get that angle for that one. When you do that, let me tell you what you get, because I don't, I'm using my calculator. I know it's going to give me a negative angle, I believe. 9 divided by 7. So it's giving me alpha, yeah, it's gonna give me an alpha that is equal to negative 9.9097531579. So it gives me that. What it did, it gave me this angle, like that, right? But when you're putting it into the system, they don't want you to put it like that. They want you to put this angle. That's a reference angle. So in order for you, these two angles are equal to each other. So for me to find this angle, but refer to it this way, all I have to do is add that to a 2 pi. So if I add this to 2 pi, is going to give me the blue angle, which is equal to the red angle. Only this is going, one is going clockwise, one is going counterclockwise. So by doing that, I'm going to use the counterclockwise of the angle. So let's add it to 2 pi. I get alpha is 5.3734. So since we want again round this to 3 decimal points, we say alpha is that. So what do I do here? I'm just going to write my angle, my solution. I'm just going to erase that. And I'm going to write my solution. X of t is equal to C is 0.439 e to the negative t. And then I'm going to write it as cosine. That whole thing is the coefficient of cosine of omega t, but omega in this case is 1t. You don't have to put 1. Minus that angle, 5.737. So let's find the other one now. For the other one, again, you have to do the same analogy for this one. We are going to do the same analogy. We have a cosine's coefficient is negative and sine's coefficient is positive. So cosine is negative here. Sine is positive here. That's what we have. We have a negative and a positive. So that puts our angle here. So that's what we're looking for. We're looking for this angle. So to find that angle, we already know the same logic. Tangent of alpha is equal to sine of alpha over cosine of alpha, and your sine is 2/13 divided by negative 7/26. So out, in, you get 2 times 26, it's a negative, 7 times 13. So 26 and 13 are reduced, you get 2 and 1, you get negative 4/7. So alpha is inverse tangent negative 4/7. Remember, when you do this using a calculator, it's going to give you that angle, because tangent is negative here and here. So you're just getting an angle that is clockwise. So it's going to put you here, but we want to find it in this location in the second quadrant. So let's find second tangent. I don't know what happened. Okay, hopefully I still have my data. Okay, so I lost some of the things I had written down. So we have 2/13 divided by negative 7/26. We said this is going to be a negative, is going to be a negative 4/7. So alpha is inverse tangent of negative 4/7. Negative 4 divided by 7. So I get alpha is negative 0.5191, But again, remember, when you're using inverse tangent, it's always going to give you that angle. Because at this location, tangent is negative because cosine is positive, sine is negative. But what we have here, we have negative 7/26. That makes your cosine negative and sine positive. So you want this angle right here. That's what you want. So how do I find that angle? Whatever this is the same as that one, and that is right now this value. So how about if I add a pi to it? If I add a pi to this much, it's going to give me that angle. So when you are in the second quadrant and you have a negative alpha, your alpha is negative, just add pi to it to find this angle. But you want to find this angle. So you add a pi to it. And it becomes, when I add pi to this, I get alpha is 2.622. So now I'm just going to go back up here and there's no answer. Plus 0.310, that's my C. Cosine omega is 4t minus my angle, which is 2.622. Let me just make this looks cosine 4t minus 2.622. And that is your answer to graph it when you choose a graphing calculator.